Good evening and welcome to this video for the 2013 Level 2 Calculus exam paper. So question 1, a function f is given by f of x equals to 4x squared minus 5x plus 2. Find the gradient of the graph of f at the point when x equals to 3. So whenever you see the word gradient, that obviously refers to finding the rate of change of a function, which is found by finding the gradient function or the derivative of the function. So the derivative of the function f of x will be f dash of x, and that is equal to 8x minus 5, because you take the power and you multiply by the coefficient and you take the power down by 1. So therefore f dash of x equals to 8x minus 5, and if you substitute the point x equals to 3 into the equation, you'll find the gradient at the point x equals to 3. So f dash of 3 equals to 8 times of 3 minus 5, which equals to 24 minus 5, which equals to 19, which is our final answer for this question, and this is just an achievable question. Question B, for a function g dash of x equals to 6x squared minus 5, the graph of g passes through the point 1, 4. Find the function g of x. So in this question, we're going to be integrating to go back to our original function g of x, because this is our gradient function, so we're going to be integrating back in order to find our original function. So therefore, g of x equals to the integral of 6x squared minus 5 dx. So g of x equals to, so if we increase the power by 1 and divide by the new power, so 2 plus 1 is 3, 6 divided by 3 is 2, so 2x to the power 3 minus 5x plus c. In order to find our c value, we substitute the point 1, 4 back into our g of x, so we know it passes through x equals to 1, y equals to 4. So 4 equals to 2 times of 1 cubed minus 5 plus of c. 4 equals to negative 3 plus c. Therefore, c equals to 7. So therefore, g of x equals to 2x cubed minus 5x plus 7. And that is just another achievable question. Question C. An emergency flare is fired from a boat. Its height, h meters above the surface of the water, is given by h equals to 90t minus 5t squared plus of 2, where t is the time in seconds since the flare was fired. What is the maximum height reached by the flare? So the maximum height is referring to when the gradient equals 0, because that's a turning point. So in this case, we're going to have for example, this is going to be our graph of h. So the maximum height is obviously going to be reached at the turning point, so this will be the maximum height. And at this maximum height, we know that h dash of t equals to 0, because it's a stationary point, meaning that there's no rate of change. So h dash of t equals to 0. So h dash of t we're going to find by finding the derivative, which is equal to negative 10t. Oh, sorry, 90t, sorry. So it becomes the derivative of 90t is just 90 minus 10t. And we're going to substitute 0 and find for what time this happens at. So 0 equals to 90 minus 10t. 10t equals to 90, and therefore t equals to 9 seconds. So therefore, the maximum height is reached 9 seconds after the launch. So therefore, if we substitute 9 into our h of t equation, we'll find the height after 9 seconds, which is also our maximum height. So h of 9 equals to 90 times of 9 minus 5 times of 9 squared plus of 2. So minus 9 squared. And you should get the final answer of 407 meters as our final answer. And that should be a merit level question. Okay, so this is a merit level question. To get an achieve level question, we need to find the derivative and make equal to 0. So finding derivative, make equal to 0. So t equals to 9 seconds will get you an achieved. Question D. The distance around a tree, its girth, g meters, at a time t years after it is planted is modeled by the function g equals to negative 0.005 t squared plus 0.15 t plus 0.3. When will the rate of growth of the tree girth be 0.04 meters per year? So rate of growth, that always refers to a rate of change. Okay, rate of change of the girth. Okay, so rate of change after the girth is 0.04 meters per year. So that's basically saying that g dash of t equals to 0.04 because that is the rate of change. So once again, we need to find the derivative to find out g dash of t. So g dash of t equals to negative 0.01 t squared plus 0.15. And if we substitute 0.04 into our equation, we can find when the rate of the change of the girth will be 0.04 meters per year. So 0.04 equals to negative 0.01 t squared plus 0.15. If we make equal to 0, we can get negative 0.01 t squared plus 0.11. Alright, so therefore 0.01 t squared equals to 0.11. And therefore, if we okay, so I apologize. I just realized I made a mistake. So it's actually supposed to be no t squared there. I apologize. So why is there a t? Shouldn't be a t squared there because we have t squared here. So if we multiply the coefficient by the power, we take the power down by 1. 2 minus 1 equals to 1. Okay, so I apologize for that one. Alright, so 0.01 t equals 0.11. So therefore t equals to 11. But it's time in t years, so t equals to 11 years. And that is our final answer, which is another merit level question. To get A achieved, you need to find the derivative and make it equal to 0.04. So this is the achieved. Finding the derivative and make equal to 0.04. Question E, g of x equals to negative x cubed plus 3x plus 2. For what values of x is g a decreasing function? So a decreasing function means that the rate of change is less than 0. So that's basically saying that g dash of x is less than 0 because the gradient, the slope is less than 0. So that's g dash of x. So basically we need to find the derivative again. So that's g dash of x equals to negative 3x squared plus of 3. So basically we're going to find the points where negative 3x squared plus 3 is less than 0. So therefore g dash of x is less than 0. Therefore 3x squared plus 3 is less than 0. Alright, if we solve for the x points of this equation, okay, if we solve negative 3x squared plus 3 equals to 0, we'll find the points where the gradient function is 0. We'll do that first. So we have negative 3, 0, 3. So we should find x equals to 1 or x equals to negative 1. And the next step, you should always draw an image of your function. Okay, so that's your function, negative 3x squared plus 3. Well, technically, it's your gradient function, but that's the function of your gradient function. So we're going to draw the gradient function, and we're going to look for the points when it's less than 0. So basically, this is a negative parabola, which means that's going to have a slope that is negative. So it's going to look like the sad face. Okay, negative parabola is going to make the shape of a sad face. You can just remember it that way. So this should look something like this. Okay, so this will be negative 1 and 1. So as you can see here, so this is g dash of x. So as you can see here, the g dash of x is less than 0 in this region here and in this region here, okay? So basically in these two regions here. So basically x can either be less than negative 1 or x is greater than 1. And that are the two domains for when g of x is a decreasing function. So it's either x is less than negative 1 or x is greater than 1. And that will get you an excellence grade, okay? So getting the correct domains here will get you an excellence grade. To get a merit grade, you need a... Okay, so an excellence grade is justification as well as the points. So this parabola, drawing the picture and drawing the graph of the parabola, and you can say that it's less than 0 when it's less than negative 1 or more than 1. That's good enough justification. Getting a merit grade is just the points, just to correct x is less than negative 1 or x is greater than 1. Just that by itself is a merit grade. And to get an achieved grade, you do correct derivative. So correct derivative found will get you an achieved. A curve has a gradient function f dash of x equals to mx plus 2. The curve passes through the points 2, 10, and negative 1, negative 8. Find f of x, the equation of the curve. So once again, this is very similar to question B, where you gave you the f dash of x, okay, and they wanted you to find the original equation. However, this question is actually very, very similar, okay? It's just basically, the only difference is that there's two unknowns. You have your m here that's unknown, and when you do integration, you have the constant of integration, the plus c. That's also an unknown. The two unknowns is balanced out by two known points, and you can just solve simultaneous equations in order to find your answer, okay? So it shouldn't be, it's like very similar concept. The concept is still very simple. It's just adding in, solving the simultaneous equations, okay? So f of x equals to the integral of mx plus 2 dx. So f of x equals to mx squared over 2 plus 2x plus c. So we know positive points 2, 10. So when x equals to 2, f of x equals to 10. So 10 equals to 4m over 2 plus 4 plus c. Therefore, 6 equals to 2m plus c. That's our equation number 1. And we know that negative 8 equals to negative m over 2 minus 2 plus of c. So therefore, negative 6 equals to negative m over 2 plus of c. And that's our equation number 2. And now, if we subtract these equations, so if we make a subtraction of these equations, 6 minus negative 6 is 12. 2m minus m over 2, that is 5m over 2. C minus c is 0. So 12 equals to 5m over 2. So 12 equals to 5m over 2. 12 divided by 5 over 2. So therefore, oh, I apologize. Oops. Okay, so negative 1 squared is actually positive 1. What am I doing? Okay, apologize. So this is actually m over 2. And this is positive m over 2 here. So, alright, so this is actually 3m over 2. So 12 over 3m over 2. Alright, so we should get that m equals to 8. Okay, if we get m equals to 8, then we can solve for c. Because we know 6 equals to 2m plus c. So 6 equals to 2 times of 8 plus c. 6 equals to 16 plus c. Therefore, c equals to negative 10. And therefore, we can find f of x. f of x equals to 4x squared plus 2x minus 10. That's our final answer for this question, and that will get us an excellence grade. To get a merit grade, you need to find the value of m or c, so either one of them will get you a merit. To get an achieved grade, you need to find equation found in terms of m, so either one of these equations will get you an achieved. Question 2, sketch the gradient function f dash of x for the function f of x below. So for this one, we have our original equation. So we know there's a turning point at this point here and a turning point at this point here. The turning point is when the gradient equals 0, and that's going to be where our turning points are. So therefore, that's going to be where our x-intercepts are for our gradient function, because our x-intercept is when it's equal to 0, and that's when our gradient is equal to 0. So at these same points here, so if it's a scale 1, we'll just pretend it's a scale 1. So x equals to negative 3 here, and x equals to 4 here. So on the same graph here, those will be the turning points of our parabola. In terms of the polarity, so either if it's a positive or a negative parabola, as you can see here, this is a positive cubic, okay? This is a positive cubic, and you can just remember that if it's a positive cubic, it corresponds to a positive parabola, or you can look at the left-hand side of x equals to negative 3. So if we look at the left-hand side here, you can see it's increasing. If you see that it's increasing for x is less than negative 3, that means for the same scale for our gradient function, it should be above the x-axis, okay? So that should give us that it should be above the x-axis. Therefore, in between, it should be less, it should be below the x-axis, and it should be above the x-axis when the graph is greater than x equals 4. Alright, so what the shape will actually end up looking like. Okay, so once again, I'm on the iPad, so it might be hard for me to draw. So it should look something like this. Alright, that's our gradient function, okay? And that will get you an achieved grade. That's just an achieved level grade here. So a tank is being filled with milk. The depth of the milk d centimeters at any time t minutes after pouring started is given by d of t equals to t squared over 4 plus of t. Find the rate at which the depth of the milk is changing 5 minutes after the pouring started. So rate of change, once again, we're going to differentiate, okay? So therefore, d dash of t equals to 2t over 4 plus of 1. So 2t over 4 plus of 1. So d dash of t equals to t over 2 plus 1. So we're going to try to find 5 minutes after the point started. So we substitute 5 into our gradient function, and we'll find the rate of change. So d dash of 5 equals to 5 over 2 plus of 1, which equals to 3.5 centimeters per minute. Question C. A stone is dropped into a pool. This makes circular ripples on the surface of the water. The area A of the circular ripple in square meters is given by A equals to pi r squared, where the radius is r meters. Find the rate of change of the area of the ripple with respect to the radius when the area is 49 pi meters squared. Once again, it's trying to find us to make finding the rate of change of area with respect to the radius. We have A equals to pi r squared, so we're going to differentiate with respect to the radius. So in this case, we have dA over dr that equals to 2 pi r. And we're trying to find the rate of change when the area is 49 pi meters squared. So in order to find the rate of change of the area when the area is 49 pi meters squared, is because in order to find the rate of change, we need the radius. Okay, so we need 2 pi times of r, so we can find the rate of change of the area given the radius at that time. So basically, if we substitute 49 pi into our original area, we can find what the radius is at this moment. So 49 pi equals to pi r squared. Therefore, r equals to plus or minus 7 meters. But since r is strictly greater than 0, because it's a real life scenario, okay, so radius can't be negative. So radius can't be negative. So therefore, r equals to 7. So now we can find our dA over dr by substituting radius equals to 7. So dA over dr equals to 2 pi times of 7. So that's 2 pi times 7. So that should give us 43.99 meters squared per second. Sorry, is it per? It doesn't tell us the time. Okay, so we just say we don't actually need a unit, so we just leave our answer like this. So 43.99, and that will give us a merit level grade. To get an achieved grade, we need to find the correct derivative and attempt to find r. So derivative found will get you an achieved, as well as an attempt to find r. An attempt, so we can get up to this step here, that will get you an achieved. Sketch the function h of x for the gradient function h dash of x below, given that the maximum value of h is 5. Okay, so the maximum value of h is 5, and we need to show the vertex clearly. Right, so this is our gradient function. So remember in our first question, we were going from our original function down to our gradient function. So now we're going to be doing the opposite way around. So we're going to be going from our gradient function back to our original equation. So in this case, we know that this linear graph is intersecting the x-axis at x equals to -4. And that means dy over dx at this point equals to 0. And that means it must be a turning point. Okay, so this is a turning point, which means that because it's a turning point, that means this must be a stationary point. This must be the vertex of our parabola, okay? And we can see that the slope of this graph is negative. Because the slope of the graph is negative, we know that the parabola must also be a negative parabola, because a negative parabola will differentiate to give us a negative slope since it's a concave down parabola. So in this case, on the same scale, we know that the maximum value of h is 5. So this x equals to -4 will be our maximum value, because that's going to be where our vertex is located. And this is a maximum value because it's going to be a negative cubic, which has a shape of a sad face, which is going to be here. So that's our maximum value. And that's 5, okay? So when x equals to 4 here, we know that the maximum value here is 5. So it's going to pass through the point 4, 5. And we know this is a negative parabola, which means that we can actually just draw our graph, okay? So it actually doesn't matter about anything else. So all we really need is this correct point here, and alright, okay, so as well as the maximum, we should also note down the equation of this negative line graph. Okay, so the equation of this negative line graph is y equals to mx plus c, where m is the gradient. Okay, So the m is the gradient, which is rise over run. So rise over run, if we look at this point here, is positive 3, and if we look at this point here, it is 0. Sorry, that's positive 4 there. Alright, so rise over run is actually negative 3 over 4. So that's our rise over run, that's our gradient. So y equals to negative 3x over 4 plus c. But in this case, c is just our y-intercept, which is plus 3. So y equals to negative 3x over 4 plus of 3. Okay, so if we integrate this, we'll actually find our equation of our parabola. Okay, so if we integrate negative 3x over 4 plus 3dx, that will give us the equation of our parabola, which is negative 3x squared over 4 times 2 plus of 3x plus of c. So this gives us negative 3x squared over 8 plus 3x plus c. But since we know that it passes through the point 45, we can substitute that in. So we can, if we substitute that one in, we can say that we can find the value of c. So 5 equals to negative 3 times 4 squared over 8 plus of 3 times of 4 plus of c. Alright, so we should find that c equals to negative 1, and therefore y equals to negative 3x squared over 8 plus 3x minus 1. So that's our equation of our graph. So we're going to be drawing this parabola into this, we're going to be drawing this equation into our plotted graph, okay? So for this one, you can actually just put it into your graph equation in your graphics calculator. So that's negative 3x squared over 8 plus 3x minus 1. Alright, so we should see that the intersection of the y-axis should be at negative 0, 1, and therefore we should actually be able to draw this, be able to draw this parabola, okay? So it does look something like this. Right, so that's our parabola, okay? So in this case here, in order to get your full, this is an excellence level question. In order to get your full excellence, you need your correct maximum and a correct intercept, okay? So intercept is at 0, negative 1, and this maximum is at 4, 5. So you need both points to get an excellence. To get a merit, it's just a negative parabola with maximum as 4, 5. So only this 4, 5 maximum will get you a merit. To get an achieved, it's just a negative parabola. So just a negative parabola by itself will get you an achieved. Alright, so question E, the gradient of a curve is given by dy over dx equals to 6x squared minus 12x. The y-coordinate of the minimum turning point of the curve is 10. So find the equation of the curve. So the minimum turning point is when dy over dx equals to 0. When dy over dx equals to 0, we can find our turning point. So 0 equals, 0 equals 6x squared minus 12x. So therefore, 0 equals to x times of 6x minus 12. So therefore, x equals to 0 or x equals to 2. Right, so it tells us the y-coordinate of the minimum turning point of the curve is 10. So for these two turning points, we don't know which one's the minimum turning point, and we don't know which one's the maximum turning point. We need to find the second derivative in order to find the minimum turning point and the maximum turning point. So d squared y over dx squared, that's our second derivative. That equals to 12x minus 12. And we need to substitute these 2 points in, okay? If we substitute x equals to 0, we get negative 12. So this is a negative result, which means that this is actually a maximum turning point, okay? And if we check the other point, okay, so if we substitute x equals to 2, we'll get 12 times of 2 minus 12, which gives us positive 12. So this is positive, hence this is the minimum. So therefore the minimum occurs at x equals to 2. So therefore we know that the y value is 10. So we know that the graph passes through the point 2, 10. So now we can use that information to find out the original equation. So we know that the original y equation equals to the integral of 6x squared minus 12x dx, and that equals to 2x cubed minus 6x squared plus c. We know it passes through the point 2, 10, so therefore 10 equals to 2 times of 2 cubed minus 6 times of 2 squared plus of c. Sorry, 2 cubed. Alright, so we should find that c equals to 18. Therefore, our final equation is y equals to 2x cubed minus 6x squared plus 18. And that should be a merit level question. This is a merit level question. So finding this last final answer here will get you a merit grade. To get an achieved grade, you need to find the turning point x equals to 2 and correctly identify it as a minimum. That will get you an achieved. Question F. A car is traveling at a constant speed until the car's brakes are applied. The car's speed changes at a rate given by negative 0.08 t meters per second after the brakes are applied, where t is the time in seconds since the brakes were applied. 3 seconds after the brakes are applied, the speed of the car is 5 meters per second. How far will the car travel with the brakes applied before it stops? So we know that the car's speed is changing at a rate of negative 0.08 t meters per second, and the rate of change of speed is acceleration. So acceleration therefore equals to negative 0.08 t. In order to find velocity, so we know that this is our a, v, and s. Okay, so s is our distance. So in order to go from a to v, we need to integrate. To go from v to s, we need to integrate. To go from s to v, we need to differentiate. And to go from v to a, we need to differentiate. So therefore, v of t equals to the integral of negative 0.08 t dt. And therefore, we should get that v of t equals to negative 0.04 t squared plus of c. In order to find our c value, we know that 3 seconds after the brakes are applied, the speed of the car is 5 meters per second. So we're going to say that after 3 seconds, so when t equals to 3, v equals to 5. So 5 equals to negative 0.04 times of 3 squared plus of c. So therefore, we should find that our c value is equal to 5.36. So therefore, v of t equals to negative 0.04 t squared plus of 5.36. Alright, okay, so now we need to find the distance traveled before it stops. Okay, so we know that when the car stops, that's when v equals to 0. So when v equals to 0, we can find how long it will take for the car to stop, and we can find how long the car has traveled in that time. So basically, we need to substitute v equals to 0 to find how long it takes before the car stops. So therefore, 0.04 t squared equals to 5.36. So therefore, t equals to the square root of 134, which is about 11.58 seconds. 11.58 seconds. Alright, in order to find our s of t, so the equation for our distance, we need to integrate again. Okay, so s of t equals to the integral of negative 0.04 t squared plus of 5.36 dt. Therefore, this equals to 0.04 t cubed over 3 plus 5.36 t plus of c. However, we can say that when t equals to 0, we can say when t equals to 0, s of t equals to 0. So because when t equals to 0, the car hasn't traveled any distance. We know that the distance traveled equals to 0. Therefore, c equals to 0. So now we need to substitute t equals the square root of 134 in order to find out the distance traveled. So s of square root of 134 equals to negative 0.04 square root of 134 cubed over 3 plus 5.36 times square root of 134. Alright, so we should find the s of square root of 134, that equals to 41.36 meters. And that is our final answer for this question, and that will get us an excellence grade. In order to find a merit, we need to find the distance function needs to be formed. So distance function formed will get you a merit. So distance function is here, that will get you a merit. To get an achieved grade, we need to find the velocity function. So velocity function found will get you a achieved. Alright, so for question 3, I'm going to leave that for tomorrow because it's getting a bit late now. So I hope you enjoyed this video. If you did, please drop me a like. If you have any comments, please leave it down in the comment section below. And I hope to see you all in the next video.